Hello, welcome to this video. This is 5-1 part B, and we're talking the mean value theorem. And in this video, we're going to go ahead and apply the MVT to problems from the AP exam. We'll also go ahead and look back and utilize the IVT in this lesson as well, and kind of help differentiate between when you apply those two. All right, so in the notes, example number 3, they say the function g is differentiable for all values of x. Selected values of g of x are given in the table above. A. Is there a time c for 0 less than c less than 6 such that g prime of c is equal to 2? Give a reason for your answer. So the first thing that should go off in your head is that they ask, is g prime of c equal to 2? Now watch out for AP or College Board doing AP College Board things. They may give you in the table values of g prime. Now if they do, that's IVT. In this case, I have g of x, and they're asking me, is there a time where the instantaneous rate of change at c is equal to 2? So this is an MVT, mean value theorem problem. So the first thing we need to go ahead and do is we need to satisfy the conditions. Number 1, they say that g is differentiable, and therefore continuous for all values of x. For all values of x. Now remember, our conditions are continuous on the closed interval, differentiable in the open interval. They say all values of x, so they've greenlit us for everything. Condition number 2. I now need to go ahead and I need to show that the average rate of change, g of 6 minus g of 0 over 6 minus 0, I need to show that this is equal to 2. And if I do, then the mean value theorem guarantees that there is a c value on that interval. Okay, so I'm going to go ahead and find g of 6 using my table, which is 10. Minus g of 0, which is negative 2, so it looks like 12 over 6, which gives us 2. And hey, it is equal to 2. So there we go. We now need to go ahead and write a conclusion. So they say give a reason for your answer. So we can say the mean value theorem guarantees a time c for 0 less than c less than 6 such that g prime of c is equal to 2. But I'm going to add in here g of 6 minus g of 0 over 6 minus 0, which is equal to 2. Okay, so we have just shown that there is a time for this function because the average rate of change on 0 to 6 is 2. Therefore, there has to be a point where the instantaneous rate of change is equal to 2 as well. All right, example 4. The function f prime is differentiable for all values of x. Selected values of f prime of x are given in the table above. Can you guarantee a time k for 2 less than k less than 15 such that f prime of k is equal to 5? Give a reason for your answer. Well, again, they want f prime of k equal to 5, but you have to check what's given in the table. They give you values of f prime of x. So this is an intermediate value theorem problem. I need to show that 5 is in between one of these values, So I'm going to go through my checks. Okay, so condition number 1, they say f prime is differentiable, and when it's differentiable, therefore continuous. For all x values. They tell us that in the problem. In the stem, they give us that. Number 2, I need to show that f prime of k is between my interval values, is between f prime of 2, be careful for notation, which is 1, f prime of 2 is 1, and f prime of 15, which is equal to 6. So our k value, f prime of k, that is 5. So I can say, okay, 1 is less than 5. Whoop. Let me erase 5, which is less than 6. Check. There it is. Okay, so what is our conclusion? Well, you guys are very, very used to this by now. So we can say, since f prime is differentiable, and continuous, and f prime of k, which equals 5, is between f prime of 2 and f prime of 15, comma, there is a time c, no, k. There is a time k. I keep wanting to use 0. It's 2. 2 is less than k, which is less than 15, such that f prime of k is equal to 5. Boom. Now, I want to point something out. Notice that I did use the title, the mean value theorem, in example number 3, and I did not use that here for the intermediate value theorem in example 4. Do I have to use mean value theorem, intermediate value theorem? No. Can I use intermediate value theorem, mean value theorem? Yes, you can. Now, if you get the title of the theorem wrong that you're using, you lose that point. So, if you are going to use the theorem's name, one, make sure you know the theorem's name, the title, and I would use that. Do not use abbreviations, such as MVT, IVT. But you can earn the point without even using the titles, without using the theorem's title. So, as long as you state the conditions, you can go ahead and draw the conclusion, okay? So just some food for thought there. All right, let's look at example number 5. Example number 5. For 0 is less than or equal to t, which is less than or equal to 8 hours, the rate that people leave a museum can be modeled by the differentiable function L prime of t, where L prime is measured in people per hour. Selected values of L prime are shown above. A. Do the data in the table support the idea that L double prime of C is equal to 0 for some value of C where 0 is less than C, which is less than 8? Give a reason for your answer. So, okay, well, they just asked, does the data in the table support L double prime of C being equal to 0? So I'm going to look at my table. They give us information on L prime. So they're asking about the derivative. So therefore, this is a mean value theorem problem. Okay, and I'm going to go through my conditions. 1, is it continuous on the closed interval and differentiable on the open interval? Well, they say it is modeled by the differentiable function. So I can say L prime of t is differentiable. And therefore continuous. And therefore continue. Okay, and then now number 2, I need to go ahead and show that the average rate of change is equal to the instantaneous rate of change. So my average rate of change, L prime of 8 minus L prime of 0 over 8 minus 0. I want to show that it's equal to this value right here. This is what I'm hoping for. I'm hoping for that, okay? So if I go ahead and do this, now L prime of 8, that is equal to 6. L prime of 0 is equal to 6 over 8. And this gives us 0 over 8, which is 0. Ta-da! There we have it. Okay, so our two conditions are met. We can go ahead and use the mean value theorem. So we say the mean value theorem guarantees a time C for 0 is less than C less than 8, comma, such that L double prime of C is equal to L prime of 8 minus L prime of 0 over 8 minus 0, which is equal to 0. Okay? Awesome. All right, example number 6. Example number 6. This one is fun and kind of different. So part A. First of all, the stem. Example 6. The function h is twice differentiable. Selected values for h are shown in the table above. What is the fewest number of times h of x equals 0 in the interval 1 to 9? Give a reason for your answer. Okay, so they're asking about h of x equaling 0, and they give us values of h of x. We're going to go ahead and we're going to use the IVT to help us kind of come up with an answer and also defend it. Okay, so you can think about this kind of conceptually. Think about connecting these values. What's the fewest number of times h of x equals 0? Well, if I go from -2 to 8, do I cross 0? Yes. If I go from 8 to 0, do I cross 0? Yes. If I go from 0 to 5, do I cross 0? Not necessarily. So the fewest number of times would be 2. So logically and conceptually, you can come up with that. So what we're going to go ahead and do is we're going to, first of all, state h is differentiable and therefore continuous. And then number 2, I'm going to go ahead and show that h of 1 is equal to -2 and h of 2 is equal to 8. And now I'm going to go ahead and show, okay, well, -2 is less than 0, which is less than 8. Okay, and I'm going to go ahead and I'm going to apply the intermediate value theorem. So what I've just shown is that we're going to cross at least once. Okay, so we can go ahead and say h of x is equal to 0 at least 2 times. Because, and here's where I'm going to go ahead and use my justification. Because h is continuous. And 0 is between h of 1 and h of 2. Therefore, there is a time C, I'll say between 0 and 2, where h of C is equal to 0. And this might be a run-on sentence, but gratefully they don't dock you for punctuation and syntax. So h of c is equal to 0, and what else did we know? We also know that h of 6 is equal to 0. So I have shown my 2 times. Here is my justification for the first time. Whew, man, isn't that a lot? And then here's the second one. Nice and easy. Okay, so that could have been a lot worse if I had to justify it twice. A lot more writing. All right, example number 6. 6b. We're going to go ahead and skip this one. I'm going to write skip, and you're probably like, thank God, thank God. I'm going to skip this one. We're going to come back to this idea, the fewest number of times that h prime of x is equal to 0 on this interval. Okay, and then let's go ahead and look at C here. So C, show that there must be a time r for 1 is less than r, which is less than 9, such that h prime of r is equal to -2. Okay, so now they're asking again about h prime of r. H prime of r. And this one is really fun because, a tortured idea of fun. We already went ahead and we established that h is differentiable and therefore continuous. Yes, we already established that. But common convention for the mean value theorem is to go ahead and take the average rate of change h of 9 minus h of 1, which is not over 9 minus 1. And if I pull these values, something unfortunate is going to happen. 5 minus -2 over 8. This is equal to 7 over 8. Now we were looking for a value -2. Shoot, that's not the value that I wanted. So the mean value theorem is not supporting this comment or this statement. So what we have to do is we have to look inside of the interval for an average rate of change of 2. Now, if you look at these two values, 2 to 6, look at that average rate of change. If I go from 2 to 6, we go from 8 to 0. So now all of a sudden, if I kind of amend my average rate of change, let me just get rid of this. I'm going to say, okay, h of 6 minus h of 2 over 6 minus 2. This was h of 6, that was 0. H of 2 was 8. And I have it over 6 minus 2. Which is 4. So we get -8 over 4, which lo and behold is -2. So what you've just shown is you've shown that the average rate of change between 6 and 2 is -2. And the mean value theorem, therefore, has an average rate of change on that interval that is equal to -2. So what does that mean? Well, that means that I have a value also on the interval 1 to 9. So let me go ahead and write this conclusion for us. So we can say the mean value theorem guarantees a time r where 2 is less than r, which is less than 6. And here's where I'm going to say which is between 1 and 9, such that h prime of r is equal to h of 6 minus h of 2 over 6 minus 2, which equals -2. Okay, there you go. All right, at this time, I'm going to go ahead and stop this video. We'll do example 7 at another time. Thanks for watching. Give me a thumbs up, subscribe. See you in the next video.